Chapter 6, Chemical Equilibrium. 6.3, Le Chatelier Principle. At the end of the lesson, students should be able to state what is the Le Chatelier Principle and apply Le Chatelier Principle, effect of the concentration, pressure, addition of inert gas in the constant value and constant pressure, temperature, and catalyst. Analogy of Le Chatelier principle. Let's say there is a small stall sell the product on a shore of a lake. Because it's small, the store owner keep extra inventory in the warehouse on the other side of the lake. If the warehouse is full but the store is empty, the boat move from the warehouse to the store, so that there is more product to sell. This is similar to biochemical reaction proceeding in an environment where the reactant to product ratio is greater than it is equilibrium. In other words, there is too much reactant stuff at the warehouse and not enough product at the store. The reaction is about spontaneously proceed towards of the equilibrium, which in the case shift to the right. Example, after the Hari Raya, Aidilfitri, suddenly there are a lot of the returns. There is too much product at the store. The owner has to send back to the warehouse. This is similar to a situation where a biochemical reaction is proceeding in an environment where the reactant to product ratio is smaller than at equilibrium. In other words, there is too much product while the warehouse sits empty. Again, the reaction moves spontaneously towards equilibrium, but in the case that means the boat goes in the opposite direction to the left. In our analogy, the store owner would ideally always just enough product at the store to do the good business, with the rest stored at the warehouse. He constantly compare his idea to the real situation and adjust the movement of boats accordingly, bringing product when is needed and shipping it back where there is too much at the store. So, Le Chatelier principle is formed by the Henry Louis Le Chatelier, is a French chemist. State, when a chemical system is disturbed, it re-establishes equilibrium by undergoing a net reaction that reduces the effect of the disturbance. Again, when chemical system is disturbed, it re-establishes the equilibrium by the undergoing a net reaction that reduces the effect of the disturbance. The disturbance is reduce the effect. The net reaction refers to the shift in the equilibrium position of the system to either right or left. The example, in the reaction of reversible reaction, the hydrogen react with the nitrogen and produce the ammonia. The disturbance of the addition of ammonia, example, this ammonia, the disturbance addition of ammonia, the system is already in the equilibrium, and disturbance of addition of ammonia is a reduce. The graph is a reduce, not eliminated. not eliminated. But what the happen the hydrogen and ammonia? The hydrogen and ammonia is increased. The hydrogen and ammonia is increased. This why because the reaction shift to the left because the disturbed by the addition of ammonia. So the conclusion is the Lee-Chatelier principles factor that affect the system at the equilibrium. There are 5 main factors that affect the equilibrium position on the system. First is change the concentrations. And the second is change in the pressure. Pressure caused by change in the volumes. Change the temperature. Addition of inert gas. And addition of catalyst. Thank you.